Okay, good morning. So we will continue on integral. I would like to review a bit. On Monday, we have talked about the antiderivative. Don't forget, when we are dealing with the antiderivative, you have to add constant. You have to add constant. Okay, yeah? So if you have 0, the antiderivative is just k. If 1, the antiderivative is x plus constant. E to the x, the antiderivative e to the x plus constant, and so on. Okay, so if the slope of tangent line of graph y equals fx at every point x is given by this, what if fx is just the antiderivative? Don't forget, if you have the antiderivative, you have plus constant. And for you to find the constant, you have to substitute this. Yeah, you use the f0 equals 1, and so you have the c, and you have the final result on fx. Okay, yeah. So another given possible, if you are given marginal profit, marginal revenue, or marginal cost, to find the function profit, revenue, cost, you have to find the antiderivative. Don't forget, the antiderivative is not unique up to a constant, so you have to add a constant. In general, given some rate of change of population, find the population, you have to find the integral also, yeah. And this is the definition of Riemann sum. This is just the approximation of the area, And if we are looking at the limit of the Riemann sum, when n goes to infinity, when there are infinity rectangle here, you have the real area under graph y equals fx from interval a unto b. So a should be what we usually say the lower boundary, and b is the upper boundary. Okay, yeah? By the fundamental theorem of calculus, how do I find the not the area but the sine area? So because the integral could be negative. Okay, so the by the antiderivative evaluated at b minus the antiderivative evaluated at a. We have certain example. Okay, we have certain example, and these are some properties of definite integral here. Yeah, addition. If you reverse the boundary, and if the boundary is the same, and so on. Okay, yeah, we have the example here, and we have also discussed about the graph, review of the graph. This is just a constant function, so y equals to x is just this, minus x, I have minus x, the red one, minus x plus 3, all points is raised by 3. Along the y-axis. What about this one? X squared is the black one. Y equals x squared plus 2 is raised by 2 points at every point. So the locus, it is shifted from 0 to 2. Okay, and what about x squared minus 2? The same. It is lowered 2 points. All of this y equal x squared is lowered by 2 points. So you have this one. And if you have minus x squared, so every point in this is times minus, so it will become go down. It is like reflecting with respect to the x-axis. So you have this one, minus x-axis. Okay, yeah, minus x-axis. X squared plus 1 is raised by 1 for every point. Minus x squared minus 1 is lowered 1 point. Okay, yeah. And the general is this: if you have x minus 2 squared, so you can find the locus. The roots of this is just 2. So this is at 2, the height is 0, and you have this kind of graph. And x plus 2, you have this one, yeah, because at minus 2, it will become 0. So this is at minus 2, it will become 0, and you have this. And if you want to x squared, x plus 2 squared plus 3 is just this, and raised by 3 points. What about this one? I can look at this by this, looking at completing squares. So I have x squared plus 4x plus 9, it is equal x plus 2 squared plus 5. So it's just x plus 2 squared, the red one, raised by 5 points. Okay, and this is fx when x is x to the power of n, when n is even. You can look at the first one is y equals x squared, the red one. and x to the power of 4 is the blue one. After 1, the height for the blue one is higher, but on interval -1 and 1, the height at the blue one is lower. Okay, yeah? You can check. For x equal x to the power of n, when n is odd, you have this kind of graph. Okay, it has the right hand and the left hand. It stretch to the it stretch to the minus infinity and plus infinity. Okay, this is x to the power of 1 over n root. When n is even is this, and when n is odd is this. Okay, and this is the exponential and logarithm we have already discussed. And this one is the last. This one is the last. Yeah. In case you forget, this is the last function that we should know. That is y equals 1 over x. What is this? This is just this. At 1, the height should be given by 1 because 1x equals 1. This is 1 over 1. So you have at a half, 1 divided by a half is 2. At 2, the height is given by a half. So you have this kind of figure. Okay, yeah? And you can also find this. Okay, yeah. So this is the graph y 1 over x. Okay, the indefinite integral. So the indefinite integral is just the antiderivative plus constant. Antiderivative plus constant, and you can apply of the all of the properties. So if you have integral of 5 over x plus 3 e to the x minus this, you can separate this 5 times this plus 3 times this minus this, and you can just calculate this, yeah, using the antiderivative formula. You have this one and you have this one, and don't forget the plus constant. And the example 10 is the integral of 2 to the power of x is just this. Okay, so we can conclude in this table for the direct method. For the direct method, I have this table of formula. Okay, so all of this we can solve it directly. And don't forget here x is just a dummy variable. So if I have this, okay, I have this square to the power of x, d square is just 1 over square plus 1, x to the power of square plus 1 plus a constant. Okay, the square can be x, can be y, can be z, can be whatever you want. Can be u to the power of n du equals 1 over n plus 1, or this is this is n. Okay, this is just this one. Okay, so x can be substituted to whatever we want. It is symbolized by the square here. Okay, yeah, the square here. Okay, and I also have this. This is integral e to the power of something d of something. Okay, this is just e to the power of something plus a constant. So x is just a dummy variable. You can always substitute x with another value. Okay, so now we are going to talk about the abstraction. Now we are looking at this. This is what we usually call substitution technique. So when we are dealing with substitution technique, we are going to change this integral into the direct formula. Let's see. So if I have integral 0 to 1 of this one, 2x squared minus 3 to the power of 10 times 4x times dx. Okay, yeah. We want to make this into a square to the power of 10 to make it easier. D square. If this is possible, If this is possible. Is it possible? Let's see. Let u equals the square. Square is 2x squared minus 3. Why? Because we want to make it something to the power of 10. So something should be the u, the square. So u equals to x squared minus 3. So I want to find du dx, that is the derivative of this, 2x squared minus 3, with respect to x is 4x. Okay, yeah? I can look du dx is just division of differential. So I can multiply this. So I have du equals 4x dx. Du equals 4x dx. Okay, so this 4x dx will become du. 4x dx will become du. And 2x squared minus 3 will become u to the power of 10. Very, very good. So in this case, it is possible to change it into a square to the power of 10, d square. With the square is u, 2x squared minus 3. Okay, yeah? In general case, it is sometimes it is possible, but sometimes it is not possible. Okay, yeah? Okay, don't forget this is 0 and 1 is the boundary for x. So if we change to variable u, we must change the boundary also. So when x equals 0, this is x equals 0 and x equals 1. When x equals 0, so u should become minus 3. What about x equals 1? When x equals 1, you just substitute this. 2 times 1 squared minus 3 will become minus 1. And the same for this, yeah? Minus 3. X equals 0, you can substitute this. 2 times 0 squared minus 3 will become minus 3. So u should be minus 3. So all of this, I can change this into the new variable that is u. That is u to the power of 10 times what is 4x dx is just du. Okay, yeah? Don't forget the boundary change also. The boundary change also. Because if you write it down du, then the boundary is for u variable. So you have minus 3, 0 become minus 3. You look at this, 0 become minus 3. And 1 become minus 1. Because when x equals 1, u become minus 1. So it's just this one. And we can solve this with using direct method. This one. Don't forget, this is just square to the power of n, d square, box to the power of n, d box equals 1 over n plus 1 times box, this is box, times box to the power of n plus 1. Okay. So if you have u to the power of 10 du, it should be 1 over 10 plus 1, that is 1 over 11, times u to the power of 10 plus 1, that is 11. Evaluated at u equals minus 3 and u equals minus 1. So I have 1 over 11 times minus 1 to the power of 11. Don't forget, if we are dealing with minus, put parentheses. Put parentheses. Minus 1 to the power of 11 minus 3 to the power of 11. Minus 1 to the power of 11 is just minus 1. And minus 3 to the power of 11, this is just the same as minus 1 times 1 to the power of 11. And this is the same as minus 1 to the power of 11 times 3 to the power of 11. And minus 1 to the power of 11 is minus 1. And 3 to the power of 11 is 3 to the power of 11. So it will become minus 3 to the power of 11. So you have this one, okay? Yeah? 3 to the power of 11, it's too much. We cannot handle this. We just leave this here. Okay? Yeah? Don't forget, this is not the same as 2 to the power of 11, yeah? 3 to the power of minus 1. This is not the same. This is not the same. 2 to the power of 11. Why? Why? Because when we are dealing with an equation, we are dealing with hierarchy of operation. And when we are dealing with hierarchy of operation, exponential goes before the subtraction. So you have to exponent, do the power of this, and then minus 1. You cannot have 3 minus 1 to the power of 11. No. Why? Because it means that the hierarchy is subtraction followed by exponentiation. And this is wrong. Okay, very, very careful. What about this one? What about this one? 2x squared minus 3 to the power of 10, but times x dx. Can we do this? Let's see. So we want to make this into a box to the power of 10, d box, if this is possible. So let u equals to x, when you do for exam, you can leave out this one, yeah? You can leave out this one. This is just for my comment. This is my comment, okay? You can just leave this out. You start from this. Let u equals to x squared minus 3. du dx is 4x, so du equals 4x dx. So what is x dx? X dx is I can multiply 4 to the left hand side. So I have 1 over 4 du equals x dx. Okay. Oh, okay. Then x dx can be substituted by du 1 over 4 du. And this will become u to the power of 10. So it settles. And the boundary, don't forget, it changes also. X equals 0, it becomes u equals minus 3. The same, x equals 1 become u to the power of minus 1. So we have this one will the same as u to the power of 10. X dx is a quarter times du. But a quarter can get out of integral, so I have this one. This is just a constant times a function. So a constant times the integral of this. Okay, and the integral of this we have just calculated this one. Okay, times 1 over 4. So I have 1 over 44 times this. Okay, this one. Okay, okay. So do you have any questions until this this segment, this explanation? Do you have any questions? Okay, you don't have any question. So this is the most easiest, not the most easiest. The second easiest technique, yeah. The first technique is what? Using direct method. What is direct method? I want to find just the antiderivative. Just to find the antiderivative. What about this one? This one, example 2x squared minus 3. Don't forget. If you have this one, later. So example 11, you have this one. You want to make this a box to the power of 10, d box. Is it possible? Let u equals to x squared minus 3. Then du dx should be 4x dx. Then 1 over 4 du equals to x dx. But you have x squared. So this is not possible. If you want to force this, you will end up by this integral u to the power of 10 x times x dx will become du. So you have two variables, x and u. So it doesn't work. So this is very important. If it's possible, this is a very important. Okay, so not all cases is possible to find by using the substitution technique. Okay, not all integral can be solved by using the substitution technique. Okay, what about this one? Let's see at example 10. This is square root of 2x plus 1 from 0 to 1 dx. Okay, so we want to make this into I want to make this as this. Square root of box, d box. Okay, don't forget, if you have this integral 0, you can look at this if this is d box. Don't forget, this is dx. this is the different variable. Look at this, 2x plus 1 and x. So you cannot apply directly using the direct method. Why? Because this is different. Because if, okay, yeah, square root of 2x plus 1 dx. Don't forget, this is different from this. So this is not integral of box d box. Okay, this is not the same. So you cannot have the direct method. You cannot use the direct method. Why? Because the variable is different. This is 2x plus 1. This is just x. So you cannot use direct method. So the second option is the substitution technique. Substitution technique. Can I change this into square root of box d box? What is box? What is box? Box is u. Then let u equals, what is square root of box? Square root of box is a box to the power of a half. Okay, square root of something, don't forget, square root of something is just something to the power of a half. Okay, yeah, this is just, okay, yeah, we usually leave out, okay, this kind of notation. So let u equals to x plus 1. Then du dx, the derivative of u with respect to x is 2. So you can multiply this. So you have du equals 2 dx. So what is dx? Because this is just dx. Dx is a half du. So I multiply it with a half. Multiply it to the left hand side. So I have a half du equals dx. Okay, don't forget you have the upper and lower boundary. It should change also according to your choice of u. So if x equals 0, you have to find what is u. U is substituted here. 2 times 0 plus 1 should become 1. What about when x equals 1? When x equals 1, u equals 2 times 1 plus 1 should be 3. So this one should change into integral 1 until 3. Okay. Square root of 2x plus 1 should be square root of u times what is dx? Dx is a half du. So you have this one, and a half can get out of integral. So you have a half times this. What is integral of this? This is just integral something to the power of a half d something. This is the same. You look at this, the same. So I can use the direct method with the box is changed into u. So you have a half is just a constant times 1 over a half plus 1 to the power of a half plus 1. A half plus 1 is 3 over 2. Evaluated at 3 and evaluated at 1. Okay, so what is 1 over 3 over 2? This is 2 over 3. So you have a half times 2 over 3 times evaluated at 3 and 1, 3 to the power of 3 over 2 minus 1 to the power of 3 over 2. Okay, yeah, I can make it more easier for you to see. Okay, so what is 3 to the power of 3 to the power of 3 to the power of 3 over 2 is 3 over times 3 to the power of a half, isn't it? And 3 to the power of 1 is 3, and 3 to the power of this is square root of 2. So you have this one. And the 1 over 3 over 2 is the same. This is just 1 times 1 over a half. So you have 1 times 1 should be 1. Okay, so you have this is as your final answer. Okay, do you have any question until here? We will just only discuss maybe for example, yeah, for example. Yes, for example. Okay, what about this one? Find integral x square root of 2x plus 1 dx. Okay, yeah. So we want to change this into box to the power of a half, d box or something similar. if this is possible. Don't forget, this is just my comment. This is just my comments. So you can, if you are doing the question, you can just leave this out. You can just leave this out. This is just my comment. Okay, so you want to find this square u to the power of a half, box to the power of half. So the box, the u should be 2x plus 1. U equals to x plus 1, then du dx should be 2. And du equals to 2 dx. Okay, yeah. Du equals 2 dx. Okay, you can multiply here. So what is dx? I want to find dx. Dx is a half du equals to that. We still have x here. Dx become du. This is square root of u. But what happened at x? What happened at x? But we can look at this cleverly. This is just my comment. You can just leave out when you are doing problems. If u is 2x plus 1, then u minus 1 is 2x. U minus 1 is 2x. So x should be u minus 1 divided by 2. Okay, yeah? So what is u minus 1 divided by 2 is u divided by 2 minus a half. 1 divided by 2. So you can simplify this. So what is x? X is this. U times a half minus a half times. What is this? Square root of u. Okay, yeah, this is lucky. We are not dealing with the boundary. Okay, square root of u. What is dx? A half du. So I have this one. Okay, yeah. The constant can leave the integral. So you have this. You can multiply this u over 2 times square root of u. You can multiply this 1 by 1. Okay, so you have u square root of u over 2, this one, minus square root of u times 1 divided by 2, this is this. Okay, by the properties of integral, this is just a half times, you can separate this. Integral of u to the square, don't forget this is u to the 1, u to the a half, and it will get u to the 3 over 2. So you have this. Where this a half comes from? From this. So you have this a half. A half times u to the power of 3 over 2. What about the last one? Minus a half times the square root of u. Square root of u is u to the half du. And you can multiply this 1 by 1. So you have a half times this one for the first one. Minus a half times minus a half is minus 1 over 4. Integral of u to the power of a half. And this is just box to the power of 3 over 2, d box. Box to the power of half, d box. So you can just use the formula for the direct method. So you have 1 over 4 times, what is the antiderivative of this? 1 over 3 over 2 plus 1 to the power time u to the power of 3 over 2 plus 1 is 5 over 2. So I just fill this as 5 over 2. This is just 3 over 2 plus 1, 5 over 2. Okay, yeah? Or what about u to the power of a half? 1 over a half plus 1, u to the power of a half plus 1 is 3 over 2. So you have this one. Okay, yeah? So you have 1 over 5 over 2, this is 2 over 5, times u to the power of 5 over 2 minus 1/4, a quarter, times 3 over 2, it will become 1 over 3 over 2 will become 2 over 3. U to the power of 3 over 2. Don't leave out the constant. Don't forget. Don't leave out the constant. So you have 1 over 4 times 2 to the power of 5. This cancels out. So you have 1 over 10. So you have 1 over 10. What is u to the power of 5 over 2? This is u to the power of 2, u to the power of a half. And u squared, square root of u. So you have u squared, square root of u as this. What is u to the power of 3 over 2? This is u times u to the half. Okay, yeah. So you have u. Don't forget the constant. Don't forget your problem is on variable x. So you have substitute back. U is just 2x plus 1. So you have 2x plus 1 squared. Square root of 2x plus 1 minus 1 over 6. 2x plus 1 square root of 2x plus 1 plus constant. So, any questions from this? This is a little bit hard, just a little bit. Just a little bit. Questions? No? Okay, very good. And then we'll continue. What about this is change when x times this, now x squared times this. Can we still do this? Can we still do this? Let's check. Let's check. So we want to make this into box to the power of a half, d box or something similar. Something similar. If this is possible. Okay, so the same. So u equals to x plus 1. So you have du equals to x dx. Okay, yeah? So a half du become this one. Okay, then we still have to think about what is x squared. We have to change this into u. Okay, yeah? We can look at this cleverly. U equals this. So if you have u equals 2x plus 1, this is u minus 1 equals to x. So x should be u minus 1 divided by 2. So you have this one. Okay, yeah? So this is just u divided by 2 minus 1 divided by 2. So you have this. And what is x? This one. What is x squared? This squared. So you have u divided by 2 minus 1/4 to the power of 2. And I can carry on this one. So x squared is just substitute by this. A function of u. Okay. Times. This is the same. Square root of the 2x plus 1. Okay, this is the same as this. And this is all the same as the previous one. But you have additional term. Okay, what about this one? How do you calculate this? You calculate it 1 by 1. And don't forget, calculate it with the constant also. So for the first one, the constant, 1 over 8 to the power of u to the power of 2, u to the power of half. So u to the power of 5 over 2. So this one. The second, this times this times this. So you have minus 1 over 4 u to the power of 3 over 2. And you have the last one, this times this times this. You have this one. Okay. And you can try to the same technique, this and this and this. Okay, yeah. So any question from this? Any questions, ladies and gentlemen? No, let's just continue for two last example. So find integral of ln x divided by x dx. No boundary. So can we bring this to the form that we have in the table of the direct method? Okay, yeah. Okay. Then I can let u equals ln x. If u equals ln x, then du dx is 1 over x. Then we can multiply du equals 1 over x dx. Okay. Then what is this? This is integral of what is ln x divided by x. This is ln x times 1 over x dx. What is 1 over x dx? This is du. What is ln x? Is just u. So you have u times du. Very remarkable, isn't it? I can change this form. I can change it into box to the power of 1 d box. And this is just 1 over 1 plus 1 box to the power of 1 plus 1 plus a constant. That is a half box to the power of 2 plus constant. Remarkable. So, but Pa, how do I find this one? How do I know I have to let u equals this? And the answer is exercise, exercise, exercise. I'm sorry. No other technique. Exercise, exercise. Do all of the tutorial. Do the exercise to know what is the U, to know what is the box here. Okay, yeah, I'm sorry, but you have to have lots and lots of exercise. Yeah, minimal the tutorial, minimal the homework that I have given you. You have to finish it. So integral u du. So I can use you can use the direct method. This is just a half times u to the power of 2 plus a constant. Don't forget you have the constant. Don't forget, the problem is on variable x. So you have to change this into variable x. What is u? U is ln x. So you can change this ln x squared plus constant. Don't forget, this is not the same as 2 times ln x. No. If you have ln x squared, this is equals to ln x. But what is this? This is ln x squared. Don't forget, the squared is ln x. So this is ln x times ln x. This is ln x of x times x. Very different creature. This is different creature. This is ln x times ln x. This is ln of x times x. Very different creature. Very, very careful. Very, very careful when you are doing this. So the last example. So you have this, find integral of this. Okay, in the table, I just have one formula that involves e. That is integral e to the box d box. So I want to find this one. So what is the box? What is u? Yeah, it is very simple. Why? Because it shows up e to the box. The box should be x squared plus 1. Okay, yeah, this is, you can look at this directly. So u equals x squared plus 1. To make it e to the power of box. Box should be x squared plus 1. So u should be x squared plus 1. It's obvious. So you have du dx is 2x. So multiply du equals 2x dx. Okay, yeah? So what is x times dx? X times dx. X times dx is a half du. So you multiply this 2 into the left hand side. So you have a half du equals x dx. Okay, yeah? So I can change this. X to the power e to the power x squared plus 1 dx is this is just e to the power of x squared plus 1 times x dx. Yeah, the same lah. So if you have this one, 2 times 3 is the same as 3 times 2, isn't it? Okay, yeah. So I can just swap this because in mathematical term we usually call this commutative. Yeah, if you do not know, yeah, just look at this. 2 times 3 is equal 3 times 2, so you can change this. So x dx will become a half du. And e to the power x squared plus 1 should be e to the power of u. A constant goes in front, so a half integral. So to make this, I think this is maybe this, e to the power of u du. equals this. Okay, yeah. So a half can get out from integral e to the power of u du, and so you have e to the box d box, and the integral is given by e to the power of box. So you have e to the power of u plus constant times the a half. Yeah. Okay, yeah. But don't forget we have x here. So we have to substitute back. U is 2x squared plus 1. So you have a half e to the power of x squared plus 1 plus constant. In the end, there are tons of forms that we can solve using substitution method, substitution technique. But there are a lot more that cannot be solved by this method. So we will discuss about the last technique in 2 weeks. In 2 weeks. Next week we will discuss about the application of this, the substitution method and the direct method, the integral. And the coming 2 weeks we will discuss the last technique for the integration. There are lots of technique to find the integration, but for you, in this course, we will just use 3 techniques: direct method, substitution method, and the last part, that is integration by parts technique. That is what we usually call in Indonesia integral partial. Okay, yeah. So I think that's all. Do you have any questions? Do you have any questions? Yes, name.
Saya nggak ini, tapi saya mau nanya, ini tuh tutorial berapa ya Pak kalau untuk latihan kayak di soal ini part nomor berapa ya Pak?
Look at this. Look at this. Your name Felix. This is Felix.
Yes.
Yeah. You can just look at this. Mathematica business. This one. You look at the assignment, the class notebook, I think. And you look at the kok nggak ada sih?
Kayaknya
files. Thank you, Felix. Files. I'm shocked. And tutorial. And the yang paling baru yang mana? Yang paling baru. 3 days ago. Open.
Oh.
This one. I think I have given you homework, isn't it? I have given you homework. Yeah, this is on the substitution technique. Number 5. So here you have to find what is the u here to substitute this. What is u here? What is u here? What is u here? And you can look at this. You have to find by using the substitution technique. So for this, you can just use 2 techniques because you just learn 2 techniques. Direct method, either direct method or the substitution technique, just 2 of them. Yeah, okay, the same of this.
Jadi di first week itu Pak kita bakal cuman ngeaplikasiin direct method sama substitution.
Yes, very good. Yes, very good.
Alright, thank you Pak. That's all from me.
Okay, thank you. Any more questions? I think I have given you homework, isn't it? Haven't I? Let's see. Yes, homework week 9. Don't forget homework week 9. And I appreciate if you don't do this 1 hour before the due time. Yeah, in Indonesia there is a wise saying saying this. Do you know the difference between this? This is the same. 1 times 7 is 7. 7 times 1 is 7. But it is in Indonesia, yeah. I think in Indonesia there is wise saying of this. It is better to spend 7 days and you learn for these 7 days just 1 hour, you spend 1 hour for 7 days, better than you spend 1 day 7 hours. Why? Because it connected to the brain, our brain. Okay, yeah. So if I have given you, if I have explained to you here, so trust me, in three days, you will forget about this one. In 3 days, in 3 days. So if you do not practice, you do not take notes, you do not have emotion when you are listen to what I have said, it will disappear in three days. Don't forget, 3 days. Absolutely, and apalagi kalau tidak berkesan. Kalau penjelasannya tidak berkesan, in 1 hour it will disappear. In 1 hour it will disappear. So it is better for you to have exercises 1 hour for 7 days than 1 day 7 hours. Okay, yeah, yeah, it is psychological, yeah, psychological. Okay, if you do not have any questions, I think we will have the quiz at 12:15, and you have 1 hour, so you will have just maybe 6 questions, yeah, about applying the substitution and direct method. Okay, yeah. So next week we will discuss the application in business, So I will appreciate if you watch the video first, because if you don't watch it, I think you will find it very difficult, because the explanation is rather lengthy. Okay, yeah. You can lose somewhere if I just explain to you on the synchronized session. Okay, yeah. Thank you very much.
Can I ask?
Sorry, questions? Yes.
Yeah. Can I ask?